Ladies and gentlemen, welcome back to the YouTube channel. My name is Mr. Jackson. If you've never seen me before, well, welcome. You finally have made it to the right place. But we're talking about inequalities, but when special cases arise, things like infinitely many solutions or no solution, right? In the previous lessons, we talked about solving multi-step equations with variables on one side or both sides. But now we want to hone in on, well, what happens if the variables disappear? So let's go ahead and take a look at a few examples.
I lost my phone maybe 3 years back, and I don't have an address. It's a matter of fact, but I guess you tried to drop me a line.
Now, just because we're dealing with special scenarios like infinitely many solutions or no solution at the very end, does not mean we change the process of how to solve these. We first always want to check to see, can you simplify anything on the left and the right side of the inequality symbol? That means distributive property, combining like terms. So let's go ahead and see if we can simplify anything for number one. I always have my students draw a line, write down that inequality symbol separating the left and the right side. That way they don't accidentally combine like terms where one's on the left side and one's on the right side, because then they're going to get a very, very wrong answer. So on the left side, I notice that there's distributive property. We have a 4 directly next to the parentheses. So 4 is going to be distributed to every term on the inside. So let's go ahead and tackle distributive property first. 4 times 3x is 12x. 4 times negative 8 is a minus 32. And then we didn't even touch this plus 5x or the minus 12. So I'm just going to bring it down. We have a less than or equal to that's going to get moved down. And then on the right side, which is totally different from what we're doing on the left, I don't want you to accidentally intermix these. We can combine like terms. I know these are like terms, this 12x and 5x, because they have the same variable and it's raised to the same power. So for example, these would not be like terms if 12x had an x, but 5x was actually 5x squared. Okay, so it has to have the same variable and raised to the same power. So this one works. So that's going to be 17x. And then we're going to bring down that minus 44. And then these are not like terms anymore. One has an x or a variable, and then the other one is a constant or a plain old number. But on the left side, we have two pairs of like terms that we can combine together. We have a 12x and a positive 5x that can be combined. And then we have this minus 32 and minus 12, which again are constants or just plain old numbers. So let's go ahead and combine both pairs of like terms. We get 17x minus 44, and then we bring down that less than or equal to 17x minus 44. So step one is done. We've simplified the left and the right side as far as we could possibly go. And now for number two, let's move our variables to one side. So I'm going to move this 17x from the right side over to the left side. I'm going to do that by doing inverse operations or subtracting 17x, which is going to cancel our variables out entirely. 17x minus 17x is just 0, so don't bother writing 0. Don't do 0 minus 44. It just goes away entirely. And then we are left with this scenario here where our variables are gone completely, and we have an inequality statement that we're looking at. So we have negative 44 is less than or equal to negative 44. Now, how do I know, is my final answer going to be infinitely many solutions or no solution? All you have to do is read this inequality statement, and if it's true, your answer is going to be infinitely many solutions. If it's an inaccurate inequality, then your answer is going to be no solution. So negative 44 is not less than itself, but it is equal to itself, meaning that this inequality is a true statement. Our final answer is going to be infinitely many solutions. So I'm just going to put this infinity symbol here and box it in. And now, if you're not sure how to graph infinitely many solutions, the only thing that you need to do is just put an arrow tip on the left side, another arrow tip on the right side, and all of these numbers are going to satisfy the inequality. So it's going to span across the entire number line, because no matter what number you plug in for the variable, so if you took the number 30, for example, and plugged it in here, 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 and this one here, I know it's in the way of the distributive property arrows, your inequality is going to be true no matter what number you pick on this number line or for infinity. All of these are going to be true no matter what. Okay, so let's go ahead and take a look at number two now. So draw a line separating the left and the right side. No distributive property, so we can skip that entirely, but we do have pairs of like terms here. So on the left side, 8x and minus 3x are like terms. We have a 14 and a 9. And then on the right side, which again is entirely separate from the left side, we have 4x and 1x, and then we have two constants. So now let's go ahead and combine everything. 8x minus 3x is 5x. 14 and 9 is going to be a plus 23. We have the greater than or equal to, and then we end up getting 5x plus 23 over on the right side. So step one's done. Now let's move our variables to one side. So we're going to subtract 5x here. These are going to cancel, these are going to cancel, and we're left with a very, very similar scenario where 23 is greater than or equal to 23 is a true inequality statement, meaning once again we have infinitely many solutions for number 2. So we just put our two arrow tips, one on one side, one on the other side, and then we have it span across the entire number line for number 2. Now let's go ahead and take a look at our third example before I have 3 for you to try out on your own in the practice session. So let's go ahead and draw our line again. The left side we actually can't do anything with. There's no distributive property, there's no like terms. So let's go ahead and take a look at the right side only for now. So I'm just going to rewrite the left side actually because there's nothing we can do with it anyways. We have the greater than symbol. I see distributive property on the right side, so let's do that. Negative 4 times 2x is negative 8x. Negative 4 times negative 15 is a positive 60. And then we're going to bring down that plus 6x and the minus 18. Again, can't do anything with the left side. We're just going to continue that down. Greater than symbol. And now let's go ahead and combine our like terms, which we have two pairs. Negative 8x plus 6x is negative 2x. 60 minus 18 is going to be a 42. Step one's done. Everything's simplified. Let's move our variables to one side. So we're going to add 2x to both sides. Our variables are going to cancel, and we're left with 40 is greater than 42. Well, this inequality this time around is an inaccurate inequality. 40 is not larger than 42. So this answer is actually going to be no solution. No matter what number you plug in for the variable, you're never going to get an inequality that's going to be true. Okay, that's why it's no solution, which means there should be zero graph at all. You just leave it the way it is, or there probably won't even be a graph for that problem at all. Okay, with those 3 examples done, let's head over to the practice session. Right, now we're stepping into the big leagues. Do you have what it takes to go 3 for 3 in the practice session? Grab a scratch piece of paper, solve these inequalities out on your own, see if you can get down to the final correct solution, and then if you have infinitely many solutions, show the graph just so you can get used to it. And obviously you're not going to have a graph for no solution. So try them out, and when you think you're ready, play the video and see how you did. So I'm assuming if you were trying them out on your own, you're ready to go over the answers. So let's go ahead and move into number 1. I'm going to draw that line separating the left and the right side. And then on the left side, we have distributive property right off the bat. So this 3 is going to be distributed. So 3 times 4x is 12x. 3 times negative 13 is negative 39. And we're going to bring down that plus 5x and the plus 9 because we haven't even touched that. Greater than or equal to. And then we also have distributive property on the right side as well. So the 7x is going to be brought down. This is going to be plus 10x minus 30. So distributive property's been knocked out entirely, and now we have to do combining like terms on both sides. So on the left side, we have 2 pairs of like terms. We have 12x and 5x. Then we have 2 constants here. So 12x plus 5x is going to be 17x. Negative 39 plus 9 is going to be a minus 30, greater than or equal to. And then on the right side, we have 1 pair of like terms. 7x plus 10x is 17x. Bring down the minus 30. And step 1 is done. We've simplified both sides as far as we can possibly go. And now let's move our variables to one side. So it looks like we're subtracting 17x on both sides. Our variables are going to cancel entirely, and we are left with negative 30 is greater than or equal to negative 30. Well, this inequality statement is true, meaning that our solution is going to be infinitely many solutions. So I'm going to box that in. And then our graph, we're going to have our 2 arrow tips again, one on the far left, one on the far right. And all of our numbers are going to be a correct solution for this inequality for number 1. So if you got this right, very, very nice job. Now let's go ahead and move on over to number 2. Draw our line again. It looks like the left side we legitimately can't do anything with, so I'm just going to bring that down. We have distributive property on the right side. Negative 4 times 2x is going to be negative 8x. Negative 4 times negative 12, that's a plus 48. And then we're bringing down that 6x and the minus 17. On the left side, we're just dragging that along with us. We can't do anything with it. We have the greater than, and now let's go ahead and combine our like terms. So we have two pairs. We have the x's, we have the constants. So negative 8x plus 6x, that is going to be a negative 2x. And then we have 48 minus 17, that's going to be a plus 31. Now let's go ahead and move our variables to one side. So add 2x on both sides. This is going to cancel all of our variables out once again, and we're left with 25 is greater than 31. Well, this inequality is inaccurate, meaning that our final answer is going to be no solution. And most people just abbreviate and say no sol just because they're too lazy to actually write out solution, or at least that's kind of the gist of what I figured out over the years. We just don't care to write solution, I guess. Right, and then moving on to number 3. Hopefully you're 2 for 2. Let's go ahead and draw our line. We have no distributive property, so that's nice, saves a little bit of time, but we do have two pairs of like terms. So 12x and our minus 5x. We have a negative 17 and a 24. And then on the right side, we also have two pairs of like terms. So on the left side, 12x minus 5x, that's 7x. Negative 17 plus 24, that's going to be a plus 7. We have our less than symbol. 9x minus 2x is 7x. 13 minus 6 is going to give us plus 7. Let's move our variables to one side. So let's subtract 7x. Those cancel. And we're left with 7 is less than 7, which is a inaccurate statement. Be very careful on stuff like this. 7 is not less than itself. But if it was 7 is less than or equal to 7, then it would be infinitely many solutions. This is an example where we get no sol, and a lot of kids mess this up. So this is going to be no sol. Again, we're being lazy here and abbreviating it. So no sol for number 3. And that's it for our practice problems. If you didn't get tripped up with number 3, very, very nice job. I hope this video helps you out with special cases that arise with inequalities, with infinitely many solutions or no solution. If it helped you out, leave a like on the video, comment any other topics you want to see in the future, and subscribe. Turn on that bell for post notifications. And we'll see you in the next one with some more mathematics.
Bye.